All right, so here we go. We're in 9.3. We're going to talk about some polar, some parametric, some arc length. So we're going to talk about graph and polar, working with exactly the same thing, right? Got our polar, got our parametric, we got our arc length. All right, in the back of the book, they're saying we can identify graphs using geometry by converting the equation to rectangular. So yes, we can switch from polar to rectangular. Since many polar equations cannot be identified this way, right, we're going to graph in polar by constructing a table plotting points. You can see the patterns. We can also show how to find parametric equations from polar, so you can go back and forth. There's two different forms for the same thing, so that shouldn't be surprising. All right, we're going to end the section by finding arc length of a curve on polar, right? So you're going to have whatever the flowers are, so we're going to be able to figure out how long that petal is. All right, so graph the polar equation, right? R sine theta. So you got to make sure you're changing your mode on your calculator if you're going to use that technique. Then it says find the polar equation, okay, for this, find the parametric. So right now it's in polar form, so you're going to switch the form. All right, so graphs of polar, right? Here's some of the fancy names for cardioids. So it's going to look like a heart. This is some like how it's going to be fixated on like which axis, right? Positive x, positive y, negative y. And then the A in front kind of tells you how long away from that center point that it's going to be. So they would call that a pole in polar, just to make sure we're using the correct terminology. All right, so this is just to talk about, right? So we're going to go through this. So if we're going to do this table technique, right, I'm going to put in various thetas that I know the answers to. Right, I'm not going to just pick pi 12ths or something that I don't know, that doesn't make any sense. And then I'm going to get those results. So I've got my theta and my r, right? So when they give the coordinates, usually it's r comma theta, right? But we've got to put in the theta that's like the x, right? And here's the output. So then we start plotting so that at angle 0, right? Angle 0, here's positive x. Our radius is going to go out 1, which is why we're going to have that it's r comma theta on the graph here, right? Because it isn't like an xy, because this circle goes all the way around. So then there's my first data point. So pi 6th and 1/2. So if I go out pi 6, I'm at a half. Pi halves, I'm at 0. So I'm thinking I'm at this vertical pole here, but I didn't go anywhere. That center point gets kind of weird because you could be going any direction. Repeat, 5/6, right? You see the symmetry of the heart there. 1 pi, you can read, I understand that. Some people like to put them together to have your coordinates, so you have your r theta, so it's easier to plot your dots. And if you're going to go in theta order, then it's easier, so you know I started here. I know I've got to go dot to dot in this direction. And there's your graph, okay? So then that's part A. And that's what it would look like on the calculator, right? You got to change your window, obviously, and go from there. So part B, so we can obtain the parametric equation by using conversion formulas, so that you're going to have to use this a lot. So x is equal to r cosine theta, y is equal to r sine theta. Okay, so then I can switch my r out as I see fit. And in this situation, right, so since I have this r, let's see here, they got x equals r. So they're switching this r here for that r here. So if I wanted my x coordinate, I got to get rid of this r because I know what r is. So I'm going to take this 1 sine theta. I'm going to take this guy here. Let me change colors. Red's a little bit better. And he's going to go in for that r, which is why that parentheses is there. And he's going to go in for this r, which is why that parentheses is there. So if I expand this out, right, then I really have x is equal to this product, right, and y is equal to that product. So if I go ahead and start, right, I know theta went between 0 and 2 pi. So the graph started right at 1, 0. So if we trace exactly once, we're going to be going counterclockwise, which we saw in the other graph. Just wanted the equations. Just remember, they just wanted the equations. So instead of saying r and theta, right, they wanted it with x in there. But we're going to have, when you do parametric, you have 3 variables. You have your output as x and y, and you have the same input. This time it's theta. Like traditionally, it's like t. All right, same idea. But here, right, so I got my polar graph here, same idea, same idea. Okay, so then now this is a different name. It's a different structure, so it's gonna look different. You don't have to know the names. All right, we're making our table. Right, same idea, common thetas here, figuring this portion out, putting your r and theta together. Realize this is theta, this is r, but you go r theta, don't put them in the wrong order, and then you're building it. So graphing by hand, it's maybe annoying, but it shouldn't be hard. And you should also know how to graph in the calculator, which is typing. Very often here when you're graphing these, they're gonna want these, especially out of the textbook. They want some arrows in there to show which direction you're headed. So don't be surprised by that. There's our picture. So let's count. Okay, same idea here. So if we want to change this to be x and y, I know my x is r cosine, my r is y sine. I know what my r is, so I'm going to take that expression, right, and put it in for r, and put it in for r, and then I have my x and y. All right, same idea. They're going to ask for like the direction, okay? So we have to know where we're going to start and then which direction you're going to go. Polar. All right, here comes another one, okay? So now we've got an inner loop, same idea, same structure, right? We're going to plot some points, we're going to plot some points. So here we're starting at 3, 0, right? So we're heading this direction. Now this one has the inner loop, which is why you need the arrows here, right? So I'm coming on this side, right? Then I'm exiting on that side. All right, just to make sure you see the flow of what's happening. All right, again, we have our r. We know x is r cosine. Put that in for r. Y is r sine. Put that in for r. We started at 3, 0 and is traced in the counterclockwise direction. So this is saying once because sometimes between 0 and 2 pi, sometimes you just double up. You just need to go all the way through pi. All right, another name over here. Again, no, doesn't matter to me if you know the names. If you do, it's gonna go faster for you. You're gonna know what the picture is, but I think they're asking for this again. It's really not that important. All right, same structure here. We can see we're starting at 2, 0, and you can see they stopped here at pi in the chart, but we didn't complete, right, all of these petals. They're not all done. Okay, so I started here, right? I'm wrapping around this way, I'm wrapping around this way, and I'm coming over here, where we stopped at 2 pi, because that's where we stopped. If you keep going, right, then obviously you're gonna finish off some of the petals. Straight up deleted it because it's the same set of 3. It looks like we're gonna have 3 here, right? But we have 1 full one, right, and 2 half ones. So if that went all the way through the pi cycle, if I continue through the 2 pi cycle, then I should have 1 full leaf, right, and then 2 halves. So I'm gonna get 1 full up here, then I'm gonna get 2 halves down there. All right. Process that we did before. What was that extra graph on there for? Oh, they finished it off. This is finishing off all the way through 2 pi, so you got your, instead of 3, right, it ended up with 4, right? You have 4 petals. Again, it should make sense. Oh, here it comes. Hold on. All right, we started at 2, 0. We exactly one time we traced, and we were going toward the left. All right, here just more names, right? You're gonna do the same thing. All right, so this one doesn't have any symmetry. Okay, so there is no number theta for which we're gonna hit 0, which is fine. So the graph does not contain a pole because of that. So everybody is positive, everybody is increasing. So as r goes to 0, right, we're gonna go negative infinity. So as you go smaller, so it's gonna make a spiral. But you see, right, we don't actually go to 0. You get smaller and smaller, but you're not actually gonna go there. And it just makes a spiral. It's kind of nice looking. Right, we already calculated one of the data points out. You can pick whatever one you want. That one just seems like, kind of makes sense. And one of those shells in the chart, easiest ones, or whatever they talk about in nature, how math always goes to nature, maybe inside of some flowers and things like that. But otherwise, right, we're talking the same thing, right? R sine, R cosine, provided. Okay, finding parametric equations and tangent lines. So find the parametric, right, we've already done that. Our R sine, R cosine, like that's easy. So if I define the tangent line at 0, then I've got to take my derivative with respect to dx d theta, right, because theta is my input. I've got to take my dy d theta. So I have these two expressions here, but to find the equation of a tangent line, I should be having my dy dx. So I should let you know that because it was just traditional tangent line stuff. Be a surprise. So to get my dy dx, right, I have my dy d theta on the top, and I have my dx d theta on the bottom. So when you flip them, right, I would have dy d theta multiplied by d theta dx. So, right, those are going to cancel, leaving you dy dx. Okay, just making sure, following through the process here, right? This is what they had on the other slide. It makes sense. So it's like, well, where did it all go? Don't forget, they're evaluating at 0. So if this is 0, that's really a 1. That's why the e's are gone, right? That's why the e's are gone there as well. Then you're just simplifying. Okay, so then this would be my slope. Okay, so then the slope at 0 over here is going to be 5, right? Because if I put in all my zeros, you can see what's going to come out. So I have my slope of a 5, and I can continue with my problem to find since at x of 1, y is 0. Okay. Again, these are some of the names. If you want to know the names and what they look like and how they're built, you're more than welcome. I have no idea. All right, arc length of the polar, right? Make sure you're still with me here because they love the arc length. You're going to take a derivative, you're going to take an integral, and you're going to do the arc length. Like that's just going to be common. When we had the arc length before, if you remember, sometimes we had, depending on what it was, we had 1 plus our derivative, right, squared. So kind of that same idea. Right, so now we're going to have our r squared, and we have our derivative squared, going through the same idea as non-polar, rectangular, right, any other function that we had before. Is just a little bit of a shift, but it should look the same. Right, so we're going to have r squared and then dr d theta quantity squared. So find the arc length, okay, so then I've got to have my integral then from 0 to 2 of r squared plus dr d theta quantity squared d theta. Okay, so that's what I'm looking for. So then I can see my r's right there. So if I square my r, and same, like either this is going to be a typing or it's going to be pretty straightforward. So then if I take my derivative, right, so then my r prime is going to be derivative of e is e, chain rule. So then I would have to go with 3e to the 3 theta quantity squared. Make sure you're squaring that 3 because that's how you're going to get the 9. Sometimes it's going to be a setup and it's going to look just like this, right? So if I have power to a power, then you're going to be multiplying. So I would have e to the 6 theta plus 9e to the 6 theta. So then same, if I'm adding up my like terms, then I would have 10e to 6 theta. So like this would be the multiple choice. This could be the multiple choice. This could be the multiple choice, right? This could be the multiple choice, or it's just going to be straight up typing, and it's all going to be a number answer. So again, make sure you're comfortable with that, make sure you're in the right mode. And sometimes depending on, not all of the Math 9, Math 8 features are available in Polar. And as I'm speaking here, I don't remember which ones are and which ones aren't. But in the end, I don't care if it's polar. Why can't I just say this is y equals and then take my derivative? It doesn't make a difference. It's going to do the same job. So do not overthink being in the correct mode for what your task is. Here we go. See, we had it here, and then we just kind of stopped because I know how the results are going to be, and I don't want you stressing about this integration. And that is our last one. I will see you tomorrow.